Hello and welcome back. In this video we're going to talk about a potential trap in your understanding of computer programs due to an issue called aliasing, where more than one variable refers to the same object. We've tried to steer you clear of that by taking care from day one in talking about references from variable names. Variable names refer to objects that are stored elsewhere in the computer's memory. So maybe this trap won't apply to you and you can move on smoothly. But let's have a look at one of the issues with this trap. Over here on the left, we've got in Wing IDE, names is a variable name. It refers to a list that contains Fred, Mary, and Chinmay. We've seen exactly that list before. We're going to make other names refer to the same object, and we will then append to the list referred to from names a new name, which is Angus. And then we'll print out what names refers to. Okay, so that's this object here, the thing referred to from names. So I think, hopefully, based on what you've seen with lists already, you won't be too surprised that when we do this, we get names. It refers to a list that contains Fred, Mary, Chinmay, and Angus. We appended Angus to the end of the list referred to from names. But if we print out also what other names refers to, okay, this was the variable that we made refer to the same object as names before we appended to names. Okay, let's run this one and, well, actually let's pause for a second and give you a chance to see what do you think the output will be. Well, unless you've looked over here and cheated ahead, what you'll see is other names also has been extended. So although we applied the append method to the object referred to from names, the thing that's referred to from other names has also been changed. So both lists were altered. Now, if your understanding of how lists and mutation are working in the computer's memory is correct, everything's fine and nothing has caused you any concern. But some of you will be scratching your heads. So why is this? What's happening here? Well, assignment of one object to another just copies the reference. So when we had names, we created it as a list that referred to an object, and each of those indexes from that object referred to further objects, Fred, Mary, and Chinmay. Hopefully you're happy with that. Names referred to the list object, and the indices referred to strings. On the second line of this program, we made other names refer to exactly the same object. So other names refers to exactly the same object as names refers to up here. So this is the state of the computer's memory after other names equals names. What happens next when we append Angus to this is we are just adding another element to the list object here, and it's referring to Angus. So when the object from names gets changed, necessarily the object referred to from other names also gets changed because they are aliases for the same object. This is a really important issue. Hopefully one that's causing you no problems right now, but you need to be very cautious about it in your understanding. Okay. You can use the Python tutor, which we used earlier on in the course, to visualize exactly what I'm showing in these little images here. So experiment with that if you're concerned about this. So how to avoid problems with aliasing? Well, if other names were supposed to be referring to a completely different object, we'd have had to use a different structure to get a copy of an actual copy of the list of objects from names. So be wary of any assignment of the form A equals B when B is a mutable object. And lists, as we've already said, are mutable. We can change the set of values referred to from any particular list, and we can change the size of the list itself, the number of objects referenced from that list. So one whose values can be changed, as any changes will apply to all aliases. If you have multiple variables referring to the same piece of the computer's memory and the object at that piece of memory changes, then all of the variables referring to that object will obviously be showing the same outcome. This isn't a problem with the types we've encountered prior to lists, because ints, floats, strings, tuples, which we haven't seen yet but we'll see soon, they're all immutable. The object itself cannot change. Once it's been instantiated on the computer's memory, it's fixed and immutable. But lists, because they can mutate, they're the first place where we've really had this potential confusion arise. So if you want to make a copy of a list and have a different list, the best way to achieve that is to use slicing. So for example, if we said other names equals names colon, what this does is it's giving us a new piece of computer's memory. Other names is referring to a new object that is a copy of all of those objects referred to from names. So starting at index 0 and finishing at the final index, we've missed both the beginning and the end index here for our slice. So that's giving us a copy of all of those values. And this time, if we run it, when we append to names, we influence only the object referred to from names. Because we have result. So if names refers to a piece of the computer's memory that's here, containing Fred, Mary, and Chinmay, other names now refers to a different piece of the computer's memory, because we've copied all of those and put them elsewhere on the computer's memory by slicing. So this time what we'll see when we run this is names has been changed by the appending of Angus, but other names has not been changed by the appending of Angus to the object referred to from names. Reason being, other names refers to a completely different object on the computer's memory. Aliasing problems can still arise due to following slicing, because it's making what's called a shallow copy. But deep copies, that's something we'll leave for later in the course. Okay, hopefully that's helped you out in your understanding of memory. Work with it and ask your tutors if you're having difficulty with that. Thanks.